This is section 3.02 of the Unit 3 notes, scatterplots. Today I am, as in you are the student, identifying key features in scatterplots so that I can identify clusters, outliers, and solve problems with scatterplots. I will know I have it when I can interpret scatterplots and solve problems with scatterplots. The specific TEKS we're looking at for today's lesson is 9A. Scatterplots. In a scatterplot, two sets of data are plotted as ordered pairs in a coordinate plane. Scatterplots can reveal key features of a data set that may not be obvious in a table. So, just like with other graphs that we've looked at, double bar graphs, histograms, circle graphs, line graphs, etc., scatterplots is another type of graph that, when used, could reveal insights into a data set that may not be obvious by just looking at it from a table or in a different form. So, on the graph to the right, you can see the x and y axes are two different types of numbers. The x-axis is the average sleep per night in hours, and then the y-axis is the age of that person. And the trend that you can see from the scatter plot, you can see that as the number of hours as the number of hours increase, the age decreases, meaning that the younger you are, the more you sleep. The older you are, the less you sleep per night. So we can look at these things and just kind of determine the patterns of the data set. We can also see, like within our sample size, clusters happening within the data set, meaning there's a group of people that are answering very similarly in the data. Then we could also see in that data set outliers that are just away from the norm, like this little dot right here that's away from the general trend of the data. This is also an outlier. This is called an outlier. So things like that in a scatter plot is what we can do among a whole bunch of other different things, but these are just some things to think about. So like I said, a cluster is a group of points located close together in comparison to the other points. And we can see there's a cluster of data values right there that is basically telling us there's a group of people that are answering very, very similarly to each other. And then we have an outlier. Outlier is a point that doesn't fit well with the rest of the points. It may be far away from the other points, or it might not follow the trend or pattern that the other points follow. And outliers with data sets could potentially skew the data in a way that doesn't really reflect the overall trend. So these outliers, they can potentially skew the data. So you may want to think about or consider that when looking at data. This point does not generally fit into the general downward trend. Okay, so example. Which statement is true? So now look at the graph. We have a graph of age in years and then a length in feet on the y-axis. Age is in the x-axis. Which of these statements is true? A, B, C, or D? A. This scatterplot has two clusters and one outlier. This scatterplot has no clusters and one outlier. This scatterplot has one cluster and no outliers. This scatterplot has no clusters and no outliers. So I'm going to give you all about 15 seconds to think about that, and then I'm going to reveal the answer. So go ahead and think. Okay, and the answer is D. This scatterplot has no clusters and no outliers. Y'all may think that this is a cluster, but it has to be close together compared to the rest of the data. So an easy way to kind of think about it is look at these lines and how they're connected. Look how these dots are far apart. Now if I connect these dots, do they show me anything weird? Or do they all generally look the same? Now from my point of view, from my opinion, yes, they look all the same distances. Now if we had some more dots put in together, then we could probably say they're clusters. Clusters there means that they are grouped in much closer compared to the rest of the data. When I'm comparing that to the rest of the data, they are not. They look normal to me. So there are no clusters. And there are no outliers. We don't have a point that's just away from the general trend of the data. So D makes the most sense. So that's this example. That's how you would look for clusters and outliers. Okay, I would normally do this in class, but y'all are just going to pause the video and try this on your own. Which statement is true? So look at the graph, look at the options. Which statement is true? A, there are no clusters or outliers. B, there is an outlier but no clusters. C, there is a cluster but no outliers. Or D, there are one cluster and one outlier. So go ahead, pause the video if you want. See if you can figure out which one of this is the correct answer. If you're on ClassKick, you can move this box to check your answer and try it out on your own. Otherwise, I'm going to continue on and show you all the answer. So the answer to this is B. There is an outlier, but there are no clusters. Okay, so B is the correct answer. Again, just like I was showing y'all in the previous example, look at these dots. Notice how they all tend to have the same distance apart from each other. Okay? So, and I'm only drawing lines to kind of show you their relation to the other points, but I don't see anything that signifies that it's a cluster. And again, cluster is points that are grouped much more closely compared to the rest of the data. These, while they are grouped, aren't closer compared to the rest of the data. They look relatively the same as the other sets. So there are no clusters. However, we do see an outlier. You look at the bottom right there, it's very much away from the general trend of the data where the rest of the dots are. So we do have an outlier. Therefore, B is the only correct answer. There is an outlier, but there are no clusters. Okay, scatterplot interval scales. To make a scatterplot of the data set, you need to determine the best interval scale to use for the axis. To do that, I have a few steps here. Step 1, we're going to look at the numbers for the x-axis of the interval scale. Step 2, we're going to find the smallest number, and then step 3, find the largest. Step 4, we're going to compare the scale and the answers to your smallest and largest numbers. And then step 5, look at the interval in the answers and make sure you can count by the given interval in the table. What do I mean by all of this? Let's look at an example. I'm going to cover some of this up and then reveal it as we go over it. So, for this example, for making a scatter plot of the data set, which would be the best scale and interval for the axis that represents the amount of fluoride. Okay, so we have water in liters and we have fluoride in milligrams. Now notice what this problem asks for. It asks for fluoride. So we're only going to focus on fluoride. So best scale and interval. Step 1, we're going to look at the numbers for fluoride amounts, which we did. Step 2, we're going to find the smallest number, which is 1.1, and then find the largest, which is 3.6. Step 4, compare the scale and the answers to your smallest and largest numbers. So I have a typo in here. The scale needs to contain the smallest and largest number. So our smallest was 1.1 and then our largest was 3.6. So from 0 to 4, does it contain 1.1 and 3.6? Yes, it does. So A is a possibility. From 2 to 5, does it contain my two numbers? No. While it has 3.6, it does not have the 1.1 because it starts at 2. So B is no good. C, from 1 to 5. Yes, that's also good. So I'm going to consider that. Now, D, from 1 to 4. Again, yes. So I'm going to consider D as well. So now after step 4, step 5, look at the interval answers and make sure you can count by the given interval in the table. So I'm going to look at A, and I'm going to make a list. So from 0 to 4. Well, I'm going to make a number line, not a list. It says intervals of 2. So basically, I'm going to be counting by 2. So from 0, I'm going to go to my next tick mark, 2. And let me write that a little bit better. And then from 2, I'm going to go another 2 and go to 4. Now, look at your list of fluoride numbers. Does counting by 2, will counting by 2 hit these decimal numbers? No, it's going to skip a large amount of them. So, counting by 2, no good. A does not make sense. Now, let's think about it again, but with intervals of 0.5. So I'm going to go down right here. Starting from 0, we count 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Now, it does catch some decimals, but notice what my decimal values are. 1.1, 1.8, 1.2. 0.5 is still skipping a large number of them. So for right now, we're going to skip C and check out letter D. So starting with 1, we're going to count by 0.2. So 1.2, 1.4, 1.6, 8, and so on and so forth. And notice 1.1 gets skipped, but it catches a large amount of the decimal numbers if we continue counting by 0.2. So letter C does not make sense. D is the only one that does in this scenario. Answer is D. And that's it for this example. Okay. Again, if we were doing this in class, we would have a poll for it, but since I'm making a video over this, pause the video, read through the problem, follow the steps, and see if you can match the correct scale and interval for this problem. So problem number 2, or you try number 2, for making a scatter plot of the data set, which would be the best scale and interval for the axis that represents the number of girls. And then, of course, if you're on ClassKick, you can move the box and check out your answer, see if you're doing this correctly. So pause the video, see if you can figure this out on your own. Otherwise, I'm going to continue on and show y'all how to do this. So first things first, this is the best scale and interval for the axis that represents the number of girls. So this part of the table is what I'm looking at. Now I need to identify the smallest number and the largest number. Smallest number in this case looks like it's a 3, and then the largest number is 13. So I know my answer is going to be between 3 and 13. So let's look at A through D. 0 to 15, that's a possibility. Again, same thing with B for the scale. So while 0 and 40 do contain our smallest and largest numbers, it's way too large of a spread. So C and D, no good. All right, now we're going to compare the intervals. So if we count by 1, are we going to catch all of these numbers that are in the list? So let's think about this. So starting from 3, we count by 1. We go 4, 5, 6, 7, 8, and you can continue that all the way to 13. Are we going to catch all the numbers of girls in the data set? Yes. So A is a big possibility. Let's check B and make sure. So if we start at 0 and we count by 5, we go directly to 5. Count by 5 again, we go to 10, 15, etc. Do we catch a majority of the numbers for girls? No, we don't. We skip a lot of them. We go straight to 5, 10, 15, and we miss a lot of these even and odd numbers right here that are between 0, 5, 5 to 10, etc. So B is not our choice. A makes the most sense. And then you can check your answer right here to see how that works. And there we go. That's it for you try number 2. Okay, here's another scatter plot problem. Scatter plot shows how many desks and computers were found in 12 different offices. How many offices had 11 computers? So, again, notice what it's asking. It's asking for 11 computers. So, this graph, this scatter plot, has desks and computers. Notice that computers are on the y-axis. So we're only interested in the values on the y-axis. And we're specifically looking at 11 computers. So, of all these dots right here, which one aligns with 11 computers? And if I go and reach out for that, I can see 1, 2, 3 different dots. And so, my answer is 3. How many offices have 11 computers? 3. So be very careful with where the labels are on the scatter plot to do a problem like this. You try number 3. The scatter plot shows how many desks and computers were found in 12 different offices. How many offices had fewer than 4 desks? So be very careful. Read the problem. Read the context clues. Fewer than 4 desks. Do you include 4 in that problem? Do you want more than 4? Do you want less than 4? What does 4? What does fewer mean? So at this moment, go ahead and try this problem. See if you can get the correct answer. If you're on ClassKick, you can move the box to see how we get the answer and just to check your work in general. Otherwise, I'm going to continue on and show you all how to do this. So, how many offices had fewer than 4 desks? So we're looking at this axis right here, and we're looking at 4. So here's 4. What does fewer than mean? Fewer than means less than 4, not including the number 4. So I want everything to the left of where my 4 is located, 4 desks. So I'm not going to include these 2. And I'm going to count on the left. 1, 2, 3. 3 people have fewer than 4 desks. Letter C is my answer. That's it for you try number 3. Okay, here's another example. Parking lot can hold cars and small trucks. The scatter plot shows how many cars and trucks parked at the parking lot each day for a week. What is the daily average number of trucks parked at the lot that week? Round to the nearest tenth. So we have a scatter plot. We want to find an average. How do we find an average? Well, we add up all the values and divide it by the number of values that are in that data set. But notice how this chart... I need to move it just a little bit. There we go. Notice how this chart has values for trucks and cars. The problem specifically asks for trucks. So we need to identify the truck values of these dots. So they go as follows. This top, starting from the top, this is 5 trucks, and then we have 4, and then we have 3 3s, and then we have 2 2s in terms of trucks. These are all the amount of trucks each of these dots represents. So we want the average. Step 1, determine how many trucks were parked in the parking lot, which we just did. Then step 2, add all the values from step 1. So I'm going to take out the calculator and add them all up. 5 plus 4 plus 3 plus 3 plus 3 plus 2 plus 2. And we have 22. And then I'm going to divide it up by the amount of data values that we have. So 1, 2, 3, 4, 5, 6, 7. Divide this by 7. Round to the nearest tenth. And we get 3.1. That 4 makes it round down to a 1 because it's less than 5. So this is 3.1. That is the average. So what does this mean? The daily average number of trucks parked in this parking lot. You get about 3 trucks per day on average parked in that parking lot. You can expect about 3 trucks at any given day. Well, 3.1, but you can't have 0.1 of a truck. So 3 trucks makes more sense when you put it in the context of the word problem. Anyways, that's it for that example. Let's go to this one. You try number 4. A parking lot can hold cars and small trucks. The scatter plot shows how many cars and trucks parked at the parking lot each day for a week. What is the daily average number of cars parked at the lot that week? Round to the nearest tenth if necessary. So, again, pay attention to what it says. Daily average of the number of cars. So you're going to be looking at one part of the scatter plot and using the numbers for cars for your daily average. Okay, and here are the steps to remind you. Here are the possible answer choices. So go through the work. Check your answer if you're on Class Kick behind that box to see if you're doing everything correctly. And yeah, pause the video to try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. So, cars are what we're looking at in this problem. Step 1, determine how many cars were parked in this parking lot. So starting from the left, I have 2. And then 3. I have 2 4s. I have 2 5s. That one's skewed a little to the right, but we're going to count that as 5. And then I have 1 6. And now we're going to add those all up and divide it by the amount of dots that we have. So, grabbing the calculator, 2 plus 3 plus 4 plus 4 plus 5 plus 5 plus 6 should give me 29. Then I'm going to divide this by 7 because that's the amount of data points that I have. 1, 2, 3, 4, 5, 6, 7. Divide by 7, round to the nearest tenth. This is going to be about 4.1 cars that are on average being parked in this parking lot. So about 4 cars per week, or per day for a week. You can check your answer right here. About 4.1 cars per day a week. Which means that it should be answer A, actually, when you round this. 4.1. So that's it for you try number 4. That's it for this lesson. If y'all need anything, just let me know. Y'all have my phone number and email there. You can text or call. And after 5 p.m., though, I am less likely to answer. But, of course, if y'all need help and it's urgent, y'all can try to reach me after that time, and I'll see what I can do. But otherwise, if y'all have anything, let me know. That's all I got. I will see y'all next time. Take it easy, everybody.